Okay, area of parallelograms. In this lesson, you'll talk about, we've already discussed parallelograms last chapter. We know all these different theorems based on parallelograms. We know opposite sides are the same. We know opposite angles are the same. We know consecutive angles are supplementary. We know all these things about parallelograms already. Last step is now let's talk about how to find the area. And I remind you, when you're looking for area, you're seeing how big it is. You're not seeing how far it is around it. Okay, you're looking for how many small 1 inch by 1 inch squares or 1 foot by 1 foot squares it would take to cover this figure. That's what area is. The area addition postulate. We're going to go over this, and then I'll show you in just a second why. The area addition postulate says the area of a region is the sum of the area of its non-overlapping parts. Meaning, if you had to find the area of this shape, okay, you got this house-looking shape, and you need to find the area of this shape. The way that you find the area, because again, think about what area is. How many squares would it take to cover this? This area addition postulate says if you want to find the area of this shape, you would find the area of the square first. You would find the area of a triangle. And you would simply add those two areas together. That's the H. You'd add those two areas together because if it takes, let's say it takes 15 squares to cover that. It's going to take 28 squares to cover this. Well, it's going to take 43 squares to cover the whole thing. Okay. So now let's show you where we're going to use this. It says in the figures below, a right triangle could be cut off. You got this parallelogram here. You could slice off a right triangle from that parallelogram, simply move it to the other side, and look what you got. It's a rectangle. The base of this parallelogram, because you just tack this part on over here, the base of this parallelogram is identical to the base of this rectangle. The height of this parallelogram is identical to the height of this rectangle. So that's the reason a parallelogram is going to have the exact same area formula as a rectangle. Area equals length times width or base times height when you deal with a rectangle, and area is equal to base times height when you deal with a parallelogram. So there's your formula. And I think we've already got that in our notes. Should have. Now be careful because sometimes you're going to have these things flipped around. It says find the perimeter and the area. And we know from previous chapter when you're dealing with a parallelogram, opposite sides are not only parallel but opposite sides are congruent. If this is 10 inches, this is 10 inches. If this is 4 inches, this is 4 inches. And Riley, what would be the perimeter of that?
28.
Perimeter is 28. 10 plus 10 plus 4 plus 4 gives you 28. E equals 28. Can't get my pen to work today. Now let's talk about the area. Area is equal to base times height, which by the way is 28 inches. There we go. Area is equal to base times height. Now you got to be careful. This thing, if you're talking about height, 10 is not a height. If you want to measure how tall somebody is, you don't take the tape measure and put it on top of their head and drag it over here to see how tall they are, right? That's not a height. When you're talking about height, you are talking about a perpendicular distance. If we're discussing height, the way that this is oriented, if you're going to let this be the base, the height would be the distance from the top of this figure straight down. That would be the height if you were going to use this as your base. So let's do it a little bit different. Let me clear this and show you if you would do this. Let's see if we can spin this thing around. Y'all see that would be a better orientation for the figure because we have this height. We have this base. Okay, if this up here was 10, then this down here is 10. And that would make our height 5. So be careful when you're looking for base and height that you're looking for a perpendicular distance. So here the base is 10, the height is 5. Trace, what's going to be the area? Base times height? 50, yeah. So area is equal to 50 square inches or 50 inches squared. You can say it either way. Any question? Find the perimeter and the area. Once again, Carly, what 4 things I'm going to add up to find the perimeter? Yeah. 21, 17, 21, 17. Good job. 21 times 2 plus 17 times 2. Somebody did that for me. Perimeter is equal to 70. Good. 76 inches. And again, notice it's measured in inches. The distance, okay, it's a distance. Okay, distance is in inches. The area, I know we're going to work these. Area is equal to base times height. How big's the base? Anybody? 21. What's the height? Is 17 the height?
Yeah.
Once again, if you're measuring to see how tall somebody is, right? You don't measure from the top of their head over here. You measure from the top of their head straight down. How are you going? The dotted line is the height, right? How in the world are you going to find out the length of that dotted line? Pythagorean theorem again. You've got a right triangle. Anytime you're dealing with height, you're going to have a right triangle. A squared plus B squared equals C squared. And if you want to type it straight into your calculator, move A squared over by subtracting. And then to get rid of the square root that whole side. Square root of 17 squared minus 8 squared. Somebody type it in, tell me what you get.
Yeah, we ended up 225 instead of 225.
Awesome. So the square root of 225, so we have a height of 15. So now when we do base times height, the base is 21, the height is 15, so the area is 315. Don't check me on
8,
that.
15, 17.
It is, you're right. 8, 15, 17 is a triple. Is that right though on my area, 315? Square inches.
20.2. Yeah, you're right.
Okay, good deal. Next one. Top it off. Base times height, it's the same problem. It's the same problem, right? Except for area is going to be easy this time, perimeter is not as easy. The height of this thing is 24. But look, for the perimeter, we're looking for adding up all the 4 sides. This is 23. This up here is going to be 23. Please remember that from last chapter. But we don't have this side length. 24 is not this side length. This side length should be a little bit bigger than 24. We can find it by, again, using Pythagorean theorem. This is our hypotenuse. You've got 7 squared plus 24 squared equals C squared or X squared. So I'm going to just go ahead and take the square root of the other side. Type it straight in. Square root of 7 squared plus 20. That's a triple too, isn't it?
625. Yeah.
Which gives you 25, yeah. 7, 24, 25 is a triple. So therefore this is 25, which makes that 25. So you've got 50 and 46, giving you a perimeter of 96 feet. Area, like I said, area is going to be easy on this one. Area is equal to base times height. The base is 23. The height is what? 24. So you're simply doing 23 times 24, which gives you 552 square feet. Any questions? On this one, perimeter is easy, but we're asking to just find the area. We're not even dealing with perimeter here. Perimeter, add up all the sides. We're good. But to find the area, okay, we're missing a height. There's 2 ways that we can work this, and I'll work it both ways for you. And this is going to get back into some old stuff that we did, which honestly I'm glad because we needed a little bit more review on it. First way of working it, you just identified that this is, right here, a 45, 45, 90 right triangle, right? You have a hypotenuse of 8.5. Well, let's come over here to the side. Let me draw that triangle. In a 45, 45, 90 right triangle, 45, 45, 90, we know that the legs are the same, but the problem is we don't have either leg. What's the relationship between the leg and the hypotenuse? What do we multiply the leg by to give us the hypotenuse? Root 2. So if this is x root 2. So how do we go from the hypotenuse back to the leg? If you multiply by root 2 to give you here, then you'll divide it by root 2. So what you can do is just on your calculator, type in 8.5, oops, 8.5 divided by the square root of 2. Oops. 8.5 divided by the square root of 2, and it gives you what?
6.01.
6.01. And again, what I would do is I would not clear my calculator. I would leave that on there. So my height is 6.01, right? So to find the area is simply base times height. So you just multiply this times 15, and you get, I think, 90.15, right?
Yeah.
Millimeters squared. Now the second way of working it. The second way of working it, if you don't remember 45, 45, 90 right triangles, if you didn't remember your shortcut, I need a height. It's a right triangle. I know this is 45 degrees. I need a height, and I'm given that this is 8.5. Anytime you're dealing with right triangles, you've got angles, you've got sides, you're missing other sides, you're missing other angles, you can always use SOHCAHTOA. Here's my angle that I'm given. This is the opposite side. This is the, careful, hypotenuse. You're dealing with a problem that has looking for an opposite side. You're given a hypotenuse, so that's a sine problem. Set you up an equation. The sine of my angle is equal to opposite over hypotenuse. To get rid of divided by 8.5, we move it over here by multiplying by 8.5. So type into your calculator 8.5 times the sine of 45. And hopefully you get the same 6.01. You get that same height. Okay? And then base times height will give you the area. More of those. And I did this on purpose. Notice we have another 45, 45, 90, and then we have a 30, 60, 90. Since we've worked this one already, let's work the 30, 60, 90 over here. Now. I can't move it. We need a height. Let me get my pen out. We don't know what the height is. We do know that our base, though, we have a base of 32. Since the top's 32, the bottom's 32. So once I find the height, I'm in good shape. So let's come down here and let's try this 30, 60, 90 right triangle. This is 30 degrees. This is 12, and we need a height. Right? Everything in a 30, 60, 90 revolves around that short side, which is the side we're given, the side across from 30. What's the relationship between, now careful, listen to what I'm saying. What's the relationship between the short side and the hypotenuse?
It's double.
It's double it. How do I go from short side to medium side? So the height is going to be 12 root 3. And if you want to, you could actually leave this answer as exact. Dealing with ACT, if this were an ACT problem, they would leave it exact. Okay? So if my height is 12 root 3, area is equal to base times height, so that's going to be 12 root 3 times 32. To multiply those together, you can multiply roots times numbers, but I can't multiply numbers times numbers. This is simply three things being multiplied together. 12 times 32 gives me
384.
So 384 root 3 is the exact answer. Notice I put equals. That's exact. Now if you want approximate, you could have actually took that 12 root 3 and turned it into a decimal, right? And multiplied that by 32. Or we can take this 384. Watch how I type this in. I can simply do on my calculator 384 root 3, which is 384 times root 3, which is 665.1. And that's in meters squared. Again, if you didn't remember your rules for 30, 60, 90s, let's go back to this exact same problem here. Let's say I don't remember that the medium side is the root 3 times the short side. Sine, cosine, tangent. This is the opposite side of your angle. and this is the adjacent. That'd be a tangent problem. The tangent of an angle is equal to opposite over adjacent. Since the variable's on bottom, what do? Put it over 1. I turn it into a proportion. Solve the proportion by multiplying your diagonals. You get 12, and dividing that by tan 30. Somebody type that in your calculator for me. Which is about 20.78. But that's not what we got for the height over there. The height over here, we got 12 root 3. Type in 12 root 3. Yeah. It's the same answer. Except for, again, 20.78 is going to be a rounded answer. 12 root 3 is an exact answer. Area of a triangle. We've already discussed area of a triangle. We can skip down. Area congruence postulate. In order for two shapes, we've talked about congruence in the past. We've talked about triangles being congruent and all this. Just throwing this in. If two shapes are congruent, they have to have the same area. That's kind of common sense. If they're the same shape, same size, then they're going to have the same area. You already know that. We've already discussed, we've done area of a triangle already. I don't know why that's thrown in again. So we can skip that. We can skip that because we've been there, done that. Here you go. Let's work some that's got some that you're dealing with an equation here. Again, this one says find the perimeter. I do want to work these. Find the perimeter first. How are we going to do that? We'll just work one of these. Pythagorean theorem. You're dealing with 19, 41. We're missing the side here. Question mark. Pythagorean theorem, 27 and 30. 27 and 30. Let's take that 27 and 30, which are legs. Divide by 3, that'd be 9, 10. That's not a triple, right? So we're actually going to have to use Pythagorean theorem on this. 27 squared plus 30 squared equals c squared. So take the square root of that, and you get 1,629. And square root
40.36.
So this missing leg is 40.36. To find the perimeter, you're going to take that plus 19 plus 41, which should give you, that's 60 there. 60 and 40 is 100. 100.36 inches. That's perimeter. Base times height, the biggest reason I want to work this. Base times height, just make sure that you know this is not the base. When you're finding area, you're finding the area of this blue triangle. The base of this blue triangle is 19. If 19 is the base, this thing's upside down completely. We've got to measure from the top, tip top of this triangle, imagine it's flipped over, down to, straight down to the bottom. This is height. So in order to find the area, you multiply 30 times 19, which should give you 570 square inches. Now let's work on the variable. The height of a triangle is 5 centimeters more than the base. And they've done you this favor, they actually gave it to you in a diagram. The height is 5 centimeters more than the base, which means the base is unknown at B. The height would be B plus 5. The area is 52. Take first step and write down your area formula. Area equals 1/2 times base times height. Plug in everything that you know. I know the area is 52. I know the base is B. I know the height is B plus 5. My suggestion to you, so that you don't have to work with fractions, go ahead, take this 1/2 and move it over here. All this stuff is being multiplied. This is perfectly legal. 1/2 is being multiplied by these. So how do I move it over here? Since it's being multiplied, you divide, right? How do you divide by 1/2? Something divided by 1/2. To divide fractions, what do you do with it? So you're going to actually multiply by 2. 104 equals B times B plus 5. I went ahead and distributed that. These are called quadratic equations. Anytime you have squares, okay, we move everything to the same side. B squared plus 5B minus 104 is equal to 0. We factor if possible. Now remember working these, right? B times B gives me B squared. What multiplies to give me negative 104 and adds to give me 5. I'll give you a second to think about it. Here's what I do. I try to find something that multiplies to give me 104. I know it's even number, so 2 times 52, right? You could divide 2 into 104. 2. It says it's even. I know 2 goes into it. That's not going to work. Then I use my whole double half philosophy. You can double one, half the other. Or you can multiply 1 by 3 and divide the other by 3. Let's do that one too. Well, 3 won't divide into that. You could try it, but it won't. 4 will. 4 will divide into this. So divide this one by 4, multiply this one by 4, gives me 13 and 8. How about that one?
That works.
8 and 13 would work, wouldn't it? Let's go, since we need a positive 5, let's go positive 13, negative 8. So B plus 13 times B minus 8 gives you 0. So B would either have to be good or, look at your drawing. Can B be negative 13? No. Most of the time on these problems you can throw out your negative. B is 8. And you can check that. That would make your base 8. That would make your height 13. And you can check that 1/2 times base times height. 1/2 times 8 times 13 gives me 4 times 13, which is 52. Stuff those. Find the area of the parallelogram. I've thrown in several of these. Your homework sheet will have several as well. To where you're dealing with 30, 60, 90 triangles. Here you've got a hypotenuse. This is the shorter side. Somebody tell me what the shorter side will equal. 15. The reason I ask you for the shorter side because in a 30, 60, 90, everything revolves around the short side. Once you have the short side, then you've got really all your sides. So if the hypotenuse is 13, hypotenuse is 30, short side is 15. To go from short side to medium side, you're going to multiply by root 3. So your height there is 15 root 3. Your base is 28. So to find the area, you're going to do 15 root 3 times 28. You can't multiply 15 times root 3. You can't multiply 28 times root 3, but you can multiply 15 times 28. And when you do, type that in for me, Matt. Tell me what you do. Okay. So 420 root 3. I like that answer. That's an exact answer. You're building bridges, you don't make mistakes when you deal with exact answers. But most of the time, the exact answer doesn't make a lot of sense to us. Because how far is 420, or how much area is 420 root 3? We type that straight in, 420 times the square root of 3. 727.46. So about 727.5 square feet. That's the area of that parallelogram. Good job. Okay, on this one. Notice it's not a 30, 60, 90. It's not a 45, 45, 90. We're going to have to use trig for sure on this. Okay, we can't use those shortcut rules. So we have a 37 degree, and let's see, or do we? Hang on.
Already got space.
Yeah, there we go. Good job. They try to trick us, right? Area is equal to base times height. And what I want to do, let's find the area and perimeter on this just to give you some extra practice. Area is equal to base times height. Well, that's 20 times 24. So the area is 480 meters squared. But like I said, just for extra practice, let's find the perimeter too. In order to find the perimeter, this is 20 and I know this is 20, but I don't know these two sides. To find those two sides, well, let's go with this 37 degrees and this 24. The 24 is opposite of the 37, and the x is the hypotenuse. Opposite and hypotenuse is a sine problem. The sine of my angle is equal to opposite over hypotenuse. Since x is on bottom, we put a 1 on bottom. To type this into my calculator, I'm going to do 1 times 24, and I'm going to divide my answer by the sine of 37, and I should get something bigger than 24. I'm looking for a hypotenuse. If you type it in wrong, it's going to be smaller than 24 probably. So we type it in, and once you get it typed in, Dylan, see, tell me what you get. Okay, so 37.29.
I got 39.
39.87.
Oh, 39.87.
So it's 24 divided by 10.
Yeah. So there's your missing side, but we're not done. That's what x is equal to. So on my calculator, what I would do is I would keep that answer there. I'd multiply it times 2, because there's 2 of them. And then I would add what?
20.
And 40. Good. And then once you get that, that should be your final answer. What'd you get? 75.8, so about 76. So the perimeter is about 119.76 meters. Another? Find the area. Now on this one, yeah, I don't know. Let's study this one. What you're going to have to be careful of on this one. This is not the height. Does everybody understand that? That's not the height. The height would actually be, again, it's got to be perpendicular. Okay, so do you see that this would actually be the height of it? Okay, because it's got to be perpendicular to that base. So this thing spun around, and this is the base, and the height is the distance from the top straight down. So this right here would actually be the height. That's your x. You're given an angle, 40 degrees, and you're given an opposite and an adjacent. That is a tangent problem. The tangent of your angle is equal to opposite over adjacent. That's an 8. Put it over 1. 18 times 1 is 18 divided by the tangent of 40. Once you get that, Alex, let me know what x is actually equal to. I'm going to put a squiggly equal here because it's an approximate.
21.45.
So about 21.45 is your height. Okay, again, that's what we just found right there. That's the height. And you can see that's actually parallel with the other one there. So if the height is about 21.45, and again, I'd leave that on my screen and we'd clear it. If you're dealing with a parallelogram, area is equal to base times height. So all you got to do is multiply this times 22. And that gives you your area, which is about
471.93.
471.93. And I always forget to put it centimeters squared. Now, if they, here's the thing. If you're dealing with an ACT problem or whatever, and they want the exact answer, now that's a little bit tougher. If they ask you for the exact answer, now here x, or your height, I'm going to call it h instead of x here. Your height was 18 divided by tan 40. You would have to leave it like that for it to be an exact answer. Because as soon as you type that tan 40 in, we know that goes irrational. It's not exact anymore. So if you wanted the exact area, you would have to leave it like this. Area is equal to base, which was 22, right? Times height, which is 18 over tan 40. And you could write that as a fraction, multiply the tops together. You could put it as an exact answer. Just don't plug in tan 40 if they ask for exact. Here we go. Next shape, trapezoids. Again, we know things from previous chapter about trapezoids. We know that it has bases that are parallel. We know that it has adjacent angles here that are supplementary. We know that if it's an isosceles trapezoid, that all the base angles are congruent. That's your review of trapezoids. We've studied trapezoids before. And now you have this formula that we've already copied down. Area is equal to 1/2 times the height times B1 plus B2. All trapezoids have two bases, the top and bottom bases, which are parallel. That's how you can find your bases, the two that are parallel. The other two are called your sides. Make sure in your formula that you always add your bases together first. Something else, if you're looking for a height, if you're trying to solve this, my suggestion, like let's say they give you an area and you're either looking for a height or a base, what I always do first is move that 1/2 over. We move 1/2 over by dividing, since it's being multiplied by all this, we'd move 1/2 over by dividing. To divide by 1/2, you'd multiply by 2. So that'd be 2a equals, so if they give you an area, that's what you would do first. And we'll do some of those problems in just a second. One of Brianna's trapezoid-shaped totes, I believe those are also called purses, is shown. Find the amount of material. And again, we know that material coverage, we're talking about area there. Area is equal to 1/2 times the height. And again, make sure that height is this distance. And I'm not sure if they're giving us a 30 there as a height, or I'm going to assume that's supposed to be height here. Because I'm not sure, let's see, no. Well, yeah, we can. We're going to work it like it's not, because the more I look at it, the more I think that that's not going to be the height. Now, what I'm seeing here, more than likely, if they design it right, I would say this is an isosceles trapezoid, that this distance should be the same as this distance, right? Which makes this thing symmetrical. 28 is the distance from here to here. 58 is the distance all the way across. If you subtract those two numbers, it leaves you with 30. So that means 15 here and 15 here. Now you've got Pythagorean theorem to actually find the height of this purse. Everybody see how I did that? The only reason I can do that is because you have that symmetry going on. Here's your height. A squared plus B squared equals C squared. Again, we're fast at typing these in because I know that H squared is equal to 30 squared minus 15 squared, and to get rid of a square, I can square root. That way we can type it straight in, so now I have a height of what?
Square root of 675.
Which is, go ahead and give me a decimal.
25.98.
25.98 is about the height. So now back to my formula. Area is equal to 1/2 times the height, which keep in mind that's a rounded answer, times base 1 plus base 2. We plug it all into our calculator, we're done. Make sure that what I would do is leave this as exact on your calculator screen, multiply it by 1/2, and then multiply it times 86. Go ahead and we always add those first. So 1/2 times whatever your calculator screen said times 86, which gives me an area of approximately, and again I say approximately because this is not exact, what?
So what would you do? 25.
Whatever your calculator screen answer was times 1/2 or divided by 2, either way. And then take that answer, multiply it times what was in parentheses, which is 86, which gives you a rather large answer. 0.5 centimeters squared. Is that what y'all got? Got somebody else. And it does say find the material used to make the side shown. I believe it probably is going to have more than one side. It's going to have a bottom. It's going to have actual sides. So it's actually going to use more material than that. That's how much material for that side. Another one? They done us a favor here. They actually gave us a height. That's kind of nice of them. The area of a trapezoid is equal to 1/2 times the height times base 1 plus base 2. That's pretty easy. Always add your bases together first. So you got 1/2 times 38 times 157. We can do 1/2 times 38 in our head. Half times is a multiplication symbol, same thing as the word half of 38 is 19 times 157, which is equal. Notice I don't put approximately, which is equal to what?
2,980
inches squared. These are probably new to you. The area of a rhombus or a kite. Now, we could actually show you where these formulas come from. When you find the area of a rhombus or a kite, if you drew that line right down the middle, you've actually just got two triangles. Is all you. And you can find the area of those triangles same thing. But here's your actual formula. I don't think this was on that formula chart that you copied down, so you might want to write it down. A rhombus or a kite, to find the area of either shape, you do 1/2 D1 times D2. And the only thing, if you think real hard, the only thing that D could stand for is diagonal. You simply multiply the diagonals together and then take half of it. The connection between this and the triangle area formula. Well, is this diagonal right here not the same thing as the base of this top triangle? Right, and normally you do 1/2 times base times height. And then down here, the same thing, 1/2 times base times height. You're kind of putting those two formulas together because you got two triangles. So to find the area of a kite or a rhombus, 1/2 times D1 times D2. So these are actually going to be a little bit easier than the other ones. The first rhombus, this diagonal is equal to 15. This diagonal is equal to 8. Now let's go back, and as we're doing this problem, let's review. When you're dealing with a rhombus or a kite, what's going to be true about the diagonals? Two things. With a rhombus, well actually, yeah, with a rhombus, two things are going to be true.
Diagonals are perpendicular.
They are perpendicular. So if I wanted to, I could ask you several other things.
And they bisect angles.
If you're dealing with a rhombus, the diagonals bisect the angles, and they also bisect each other. Because a rhombus is a parallelogram, diagonals of a parallelogram always bisect each other, and you've got that there. See that? Bisect, bisect, that's a rhombus. So to find the area of a kite, the first one's a kite, not a rhombus, area is equal to 1/2 diagonal 1 times diagonal 2. How would I multiply this together? I do half of 8 first, which is 4. 4 times 15, 60. The second one, they're giving you that this is 10. And I hate that they even told you that they're the same. I wish they hadn't, because you should have known that from last chapter. If that's 10, then that means this is 10. If this is 12, that means this is 12. So 1/2 area is equal to 1/2 diagonal 1, which is 20, times diagonal 2, which is 24. How would I multiply that together? Do it without a calculator, guys. What's half of 20? 10. And then times 24, 240. You can do it like that too. Half of 24 would be 12. 12 times 20, also 240 square feet. Any questions? Pretty easy, right? That's enough of those. Let's try this. One diagonal of a rhombus is twice as long as the other diagonal, which gives you an x and a 2x. Twice as long. If the area of the rhombus is 169, okay, here we go. Area is equal to 1/2 D1 D2. The area is 169 equals 1/2 times D1 times D2. Everybody see how I just plugged in everything I knew? It doesn't matter which one's the first and which one's the second diagonal. You have two options here, folks. What I normally do is I take this 1/2, like I said, since it's multiplied by all this, I go ahead and take this 1/2 and I move it over here. Since 1/2 is being multiplied, how do I move it over here? You multiply by 2. You divide by 1/2, which is the same thing as multiplying by 2, which gives you 338. On this one, actually, there's an easier way, though. Can't you just do 1/2 of 2x? Wouldn't that be a whole lot easier? Now, I would use the first method if my 1/2 didn't cancel with something like this. But if you can do 1/2 of 2x, yeah, go for that. So 169 equals half of 2x is x times x, or x squared. To get rid of a square, we square root, so x must be 13. Single at 1x. 1x. Any questions? Already done it once. What I'm about to show you, simply for review before we go into sectors. Area of a circle is pi r squared. What's the distance around the circle? 300. Well, degree-wise, 360 degrees. If you're talking about circumference, though, remember how to find it? Pi times diameter, or 2 times pi times radius. Make sure you know the difference between area and circumference. What is the area of the circular putting green shown? Again, area is pi r squared. In this problem, the radius is 10. So area is equal to 3.14. Actually, I need to go ahead and put approximate there, don't I? Because pi is not 3.14. Times 10 to the second power. So about 314 square feet. That's pretty easy, right? So that's the next. Let's work it backwards. And like I said, we've already done some of these previously. This is just some review. Find the radius of a circle that has this area. Area equals pi r squared. Now let me show you something. If you're looking for a radius, we could go ahead and plug this all in. But let's go ahead and revisit some algebra stuff, and let me show you something. If you want to solve the formula before you plug in it, let's say I've got 20 to 30 different areas that I've got to plug in. You have two options. If you want to, you can plug in all 20 to 30 of those areas, divide and solve, and do it every time, actually solve the equation every time. Or, look what else you could do. Can I go ahead and divide by pi before I can solve it? Because think about the steps that you're going to use to solve this. These are being multiplied, so I can move this over by dividing. Problem is you can't divide a by pi, so you just leave it. Last step, how do I get r by itself? Square root. So to find the radius, now I can plug it into this, because I know that's what I'm looking for. It says find the radius. So now let's just plug everything in. The radius is equal to the square root of the area divided by pi. By the way, that's exact. As soon as you plug in 3.4, it's no longer exact. We'll type this one in together. Radius is equal to the square root. Now you can just do it in one step. Of 95 divided by pi. Done. Radius will be about 5.5. Any questions? So you got your options there. That's the reason we teach you how to manipulate formulas. Let's say, like I said again, that I give you 20 different areas to plug into this, and you have to solve all 20 of them. It'd be a whole lot easier to solve the formula and then plug in the areas here. Look, what if I told you to plug in every area from 10 to 20? Now you plug in 10 divided by pi, take square root. 11 divided by pi, take square root. 12 divided by pi, take square root. Instead of having to solve it every time. Okay, sectors, and this will be the last thing we do today. Area of a sector. Y'all told me a while ago, anytime you're dealing with a circle, we know from the previous chapter that you have 360 total degrees in a circle. Well, what if I want to find just the area of a portion of that? The ratio of the area of a sector to the area of the whole circle is equal to the ratio of the degree measure of the intercept of arc to 360. That's confusing. Okay, that whole thing doesn't make sense to me, so let me show you what that means. A circular pizza has a diameter of 12 inches and is cut into 8 congruent slices. What is the total area of one slice to the nearest 100? Okay, we want to find the area of a sector. What a sector is? A sector is a fractional portion of that whole circle. It's a slice. A sector is a slice. So here's the process. Okay, this is one of the easier problems, but here's the process you go through. Step number 1, find the area of the whole pizza. Find the area of the whole circle. Area equals pi times radius squared. What's the radius of this pizza here, Jagger? Since the diameter is 12, radius would be, just radius, 6. So therefore the area would equal pi times 6 squared, or pi times 36. That's exact. But that's not what it asks us for. It says find the area of each slice. All 8 slices added together has an area of 36 pi. Well, how do you find the area of one slice? Good. Divide by 8. That makes sense. That's you got now, this again, I left it exact. Can I divide pi by 8? Not without getting a decimal. Can I divide 36 by 8? Not without getting a decimal. Can I reduce 36 and 8? Sure, divide them both by 4. That'd be 9 pi over 2 inches squared. And again, I told you, yeah, that's exact, but that doesn't mean a lot to us. Approximate makes more sense to us. 9 times 3.14159 divided by 2, somewhere around 13. 9 times pi, we should be somewhere a little bit bigger than 27. 9 times pi divided by 2. And my thought was, actually that's 14 point something, isn't it?
14.13.
Square inches. That's the approximate. You could cut it up and piece together about 14 square inch tiles to cover that pizza. Now here's, I need to work another one of those. Yeah, let me make one up because I don't have another good one. Let's say that we have a 120 degree sector in a circle that has a radius of 6 inches. I want to know what's the area of that sector. You do a lot of this. We'll get into pre-calculus, which, by the way, this is very ACT. It's going to be on there. You have a 120 degree sector. And think of it like this. Here's what a 120 would look like. This would be 90. Right? Add another, let's see, this would be 180. So like that, 120 degrees. That's about a 120 degree sector. I want to find the area of that 120 degree sector. Step number 1, find the area of the whole circle. To find the area of the whole circle, you do pi times radius squared. I write these down. These are going to be the ones you have issues with on the board. Since the radius is 6, that's going to be pi times 6 squared. I think that's the same as the last one, right? 36 pi. But now on the last one, it told us we had 8 slices. Pretty much what you've got to do here is find out how many slices you got. And it is going to be 3 slices. But here's how you do it. Because what if this was an 80 degree sector? What if it was a 76 degree sector? Next step is you're going to ask yourself, this is the whole thing. This is the whole area. But I need to know what fractional portion am I finding? How many total degrees are in the circle?
360.
And I'm only looking for the area of this 120 degree sector. So I'm looking for the area of the 120 out of 360 degree sector. Again, this is 120 degrees out of the whole 360. So what you're now going to do is you're going to take this area and you're going to multiply it by this fractional part because I want this fractional part of the whole area. The word of, anytime you're dealing with fractions, means to multiply. So you're going to take your 36 pi and you're going to multiply it by, and if you want to reduce this, that's fine. That's a third. Like you said, this is 1/3 of the whole circle. If you want exact, 1/3 of 36 pi is 12 pi. That's the exact portion. But if you want the approximate, which more likely you do, 37.68 square inches. Let's work one other one. What if we take the same circle, and instead of a 120 degree sector, what if I ask you for an 80 degree sector? 80 degrees would look something like this, a small portion. Go through the same set of steps. Step number 1, find the area of the whole thing, 36 pi. Step number 2, multiply by the fractional part. You can't really find the 1/3. It's not going to clean up into a nice fractional part. So if you're looking for an 80 degree sector, you would simply take the whole area. You want to find 80/360ths of that whole area. Does that make sense? Where you go with that? It's always going to be something out of 360. Now, what about this? Do I have to reduce that 80 over 360? No. Not unless you're looking for an exact answer. You can type it in like this, guys. I need 80 3/60ths of 36 pi. Somewhere around 25.13, which should make sense. This red part had 37.68 as an area. The blue part, that 80-degree portion, would have about 25.13 square inches.